Hello everyone, my name is Nikhil sir of support classes Hatryosti Road Sholapur. We have started 8th chapter in science of class 9th NCERT, that is motion. In our previous video, we have completed some part of this topic. If you have not seen those videos, please see that videos. I have provided you those links in my description box below side. You see that and please go through those videos. Now today we will move towards the next point in this topic, that is 8.4, graphical representation of motion. Now we will see the motion in graphical representation. Graphs provide a convenient method to present basic information about a variety of events. Means graphs provide a convenient method to present basic information about a variety of events. For example, here examples are there. In the telecast of a one-day cricket match, means in our cricket match, we will see the graph of bowling speed, scores, vertical bars graphs show the run rate of a team in each over, as you have studied in mathematics. Means all these things we have studied in mathematics. A straight line graph helps in solving linear equation having two variables, and in maths the topic is a linear equation in two variables. That also we see a straight line graph help those topic. Now in next paragraph, to describe the motion of an object we can use line graphs. Now in this chapter, means motion of an object we can use line graph. In this case, line graphs show dependence of one physical quantity such as distance or velocity, or on another quantity such as time. Now we will move towards on that graph. See here, distance time graph is there. Let's we see about the distance time graph. The change in the position of an object with the time can be represented on the distance time graph adopting a convenient scale of choice. Means the change in the position of an object with the time can be represented on the distance time graph. In this graph, time is taken along the x-axis and distance is taken along the y-axis. See here in the graph, we will see it easily. See here, on x line time is there, and on y-axis distance is there. Distance time graphs can be employed under various conditions where objects move with uniform speed, non-uniform speed remain at rest, etc. Means in distance time graph can be employed under various conditions where object move with maybe it uniform speed, maybe it non-uniform speed, or remain at stationary. Now here graph is there. This is a figure number 8.3, distance time graph of an object moving with the uniform speed, and this graph is a object is moving with the uniform speed. Now this about this graph, the detailed explanation as given here, just we will see that. We know that when an object travels equal distance in equal interval of time, means when an object is moving with the equal distance in equal intervals of time. Suppose you can say in 1 hour an object covered 50 kilometer distance, second hour again it covered 50 kilometer distance. This shows that. Now we will move towards on next side of this page. This shows that the distance traveled by the object is direct, directly proportional to time taken, and this shows that distance traveled by the object is directly proportional to time. Thus, the uniform speed graph of distance traveled against time is a straight line. See here in the this graph we are seeing the distance is moving with equal interval of times. Means this is a straight line graph. Straight line as shown in figure 8.3. The portion OB you see in your textbook. Please student, put your textbook in front of you while watching this video. The portion OB of the graph shows that the distance is increasing at a uniform rate. Means see here distance, here it is near to be 10, here it is again near to be 20. It means here it is a 9 kilometer, 9 to the 18 kilometer, 9 3 the 27 kilometer, 9 4 the 36 kilometer. Means distance is traveled by an object in equal interval of time. Note that you can also use the term uniform velocity in place of uniform speed, and you can also take uniform velocity in place of uniform speed if you take the magnitude of displacement equal to the distance traveled by the object along the y-axis. Means same here, just we have to take uniform velocity in place of uniform speed. Now on next paragraph we can use the distance time graph determine the speed of an object, and this graph we used for to determine the speed of an object. To do so, consider a small portion AB. See here, the small portion is AB here. AB is there. AB of the distance time graph shown in figure 8.3. Draw a line parallel to the x-axis from point A. Means you have to draw one parallel line from the point A. See here one parallel line we have taken, and this line is parallel to x-axis, and another line parallel to the y-axis from point B. See here, from point B we again draw one parallel line, and this line is parallel to y-axis. These lines meet each other at the point C, and these lines, see here, these lines meet at the point C to form a triangle ABC. See here, one triangle is there, ABC. Here A, here B, and here C. Now on the graph, AC denotes the time interval. Where is AC? See here, AC denotes the time interval T2 minus T1, means final speed and initial speed, means final time and initial time, while BC corresponding the distance S2 minus S1. See here BC, S2 minus S1 means final speed, sorry, final distance and initial distance. We can see from the graph that as the object moves from the point A to B, means an object is first starting from here and it will become at first place, means here A, and again it goes to B. A to B, it covers a distance S2 minus S1 in time T1 minus T2. See here, we have seen that time taken and distance covered. The speed v of the object therefore can be represented, and we can represent the speed in this way. Speed is equal to S2 minus S1 upon T2 minus T1. We can also plot the distance time graph for accelerated motion, that is table 8.2 shows the distance traveled by a car in a time interval of 2 seconds. See here, if we see in this table, time in second and distance in meter. Here initial time 0 and initial distance 0. In next 2 seconds, distance covered by a car is 1 kilometer. Again in next 2 seconds, it again covered 3 meter distance. Then again in 2 seconds, it cover near about 5 meter distance. Next 2 minutes, it cover, see here 16 is there, means 7 kilometer distance covered by the car. In this way, table 8.2 is a distance traveled by a car at a regular time intervals. Now we will move towards on next page. See here, as per the previous table 8.2, the graph is there. That car is moving in a non-uniform motion. See here, after 2 seconds it covered 1 meter distance. After 2 seconds it covered 4 meter distance. Then after 2 minutes it cover 5 meter distance. After 2 minutes it cover 7 meter distance, and in this way the car is moving in a non-uniform speed. Here the figure is there, figure 8.4, distance time graph for a car moving with a non-uniform speed. Now we will see its description now. See that the explanation of figure 8.4. The distance time graph for the motion of the car is shown in figure 8.4, means here. Note that the shape of this graph is different from the earlier distance time graph, means this graph is different from the earlier graph. The nature of this graph shows non-linear variation of the distance traveled by the car with time. Means this graph shows non-linear variation of the distance traveled by the car. Thus the graph shown in figure 8.4 represent motion with non-uniform speed, and this graph shows that the non-uniform speed. I hope you understood it better. If any query is there, please student give your comment, we will solve it. And please subscribe my channel and show your thumb. Thank you.